So our study was all about IBS and the different types of treatment. So here we go. Here we have a fact sheet about IBS and then a graph. Both of these will be touched on a little bit later, so if you want to read them now, you can pause. If not, we'll talk about it in a second. So our presentation is laid out into 6 different parts. We start with the study introduction, and then our research question, the descriptive statistics, the confidence interval, the conclusions, and then lastly we have our SAS code. So here we'll go into our study introduction. What is IBS? So IBS is a gastrointestinal disease that affects the digestive system, and there are 3 different types. So we have IBS-C, IBS-D, and IBS-M. These are all dependent on what your main symptom is, so that would be either constipation, diarrhea, or a mixture of both. About 15% of people suffer from IBS, and their symptoms include abdominal pain or cramps, gas and or bloating, and then lastly, again dependent on the type you have, constipation, diarrhea, or a mixture of both. Like the graph above showed, it's more common for women to suffer from IBS than it is for men, and generally it can be treated by medication or just making changes to your diet, but overall IBS can greatly decrease a person's quality of life depending on how severe it is. With our study, the researchers believed that IBS could be treated with just placebo pills, and within that they also believed that the placebo pills would still work even if the patients knew that the pills were placebo. So this study was random, and it was a 2-week trial that involved 80 patients. The patients were more female than they were male, and on average, they were the age of 47, give or take 18. This experiment is overall comparing just the effectiveness of a placebo pill to no treatment at all, which is an important note because many studies compare an actual medication to a placebo, but in this case, we're comparing the placebo to no treatment at all. Here are our 2 levels of treatment. Again, we have the placebo, which patients were given a sugar pill with no actual medicine that would treat their IBS, and then they were made aware that this pill was a placebo and that it wasn't actually capable of helping. And then the control was a group where the patients were told to just continue their regular maintenance of their IBS with no added pills and no major changes to their diet. Here we have our variables that we plugged into SAS. So we have our observation, then the ID group, the improvement, female, which was a yes or no, female versus male, and then the next 3 were dependent on the type of IBS the person had. So again, diarrhea, constipation, or a mix of both. Then we had our main symptom, and then the last variable was the SSRM, which was also a numerical variable. So the only 3 numerical variables were the observation, the improvement, and then the SSRM, and all of the rest were categorical variables. So next we have our research question. Is there evidence that the placebo effect produces a different improvement score than the control group? So our quantitative variable that we compared is the improvement score, and it was compared to the 2 levels of our categorical variables, which again were the placebo pill versus the control. Our parameters were mu1 equals the mean improvement score of the control group, and then mu2 was the mean improvement score of the placebo group.
So these are our descriptive statistics for the data that we collected. This was our first round of descriptive statistics just based on the improvement score for the control group and the placebo group, not anything with hypothesis testing, just the proc means and proc univariate on the raw data. And with that, we found that there was 43 patients in the control group, 37 in the placebo group. There was a mean of 3.783 in the control group compared to the mean of 5.239 in the placebo group. a standard deviation of 0.999 in the control group and a standard deviation of 0.845 in the placebo group, and then a median of 3.52 in the control group compared to the placebo group's 5.29, interquartile range of 1.306 in the control group versus 0.724 in the placebo group, and then the minimum and maximums of each groups are listed here. And then next, this is our box plot for the improvement score, and that's listed on the y-axis, and then the groups, the levels of treatment that they're in, are listed on the x-axis. And again, this kind of just shows us the same thing that the numerical data was telling us, just more in a visual way. There is higher rates of improvement in the placebo group and a little bit less variability than in the control group. Next, we have another visual to look at the data, and that's the histogram that we generated. And you can see that the frequency is on the y-axis, and that's the frequency of how many times each improvement score happened in each group. And then the improvement score is on the x-axis. And again, there seems to be a higher rate of improvement with the placebo group in comparison to the control group. And then what do these descriptive statistics tell us? I kind of already mentioned it, but kind of like I was saying before, but this tells us that there is a difference between the two levels of treatment, which was our research question on whether or not there was a difference. And then with that the data shows us that there is higher rates of improvement in the placebo group than the control group. And we can look at the mean improvement score for both of those groups, along with the median scores for both of those groups. And then we can also look at the measures of spread, which show that the placebo group had less variability or spread within that data set. The standard deviation was 0.845 in the placebo data compared to 0.99 in the control group. And the range was 4.198 for the placebo group compared to 5.58 in the control group. And that just kind of shows that there is more consistent rates in the placebo group and there's less spread between all of the data points. And then for our other descriptive statistics that we calculated that weren't related to our research question necessarily, we looked at the SSRM value for both the control and placebo groups. And these are kind of what we found with the SAS data. The number of patients in each group was obviously the same. And then the average mean for the placebo group was significantly higher than the control group, the median as well, and then the standard deviation for the placebo group was larger than the control group, which was not what we found with the other data. So that's kind of interesting to look at. And then this is just a graph that we used SAS to calculate, looking at the percent of data that fell in each value, with the control group on top and the placebo group on the bottom. Like I said, this shows us that the placebo group produced higher numbers than the control group again, just like with the improvement score. And we can also look at the histogram that will tell us more information about the distribution of the SSRM between both groups. It's very normal and it's almost a perfect bell-shaped curve, whereas for the control group, whereas the placebo groups was less normal. And then these are two other graphs we generated just to look at some other numbers. On the top left, this graph right here, we looked at the improvement score within each group compared to whether or not the patient was a male or female. Red is male, blue is female, and you can see in the control group it was kind of the same. In the placebo group, the females had a little bit higher rates of improvement, which is interesting to note. And then we also looked at the improvement by main symptom that they experienced. And we can see that people that experienced, this is supposed to be constipation, but SAS cuts you off after a certain number of letters. But people that experienced constipation had the highest improvement scores.
Confidence interval. So what is our confidence interval? So essentially we use a 95% confidence interval, and this means that 95% of the time it'll likely contain our true proportions value. So that's comparing our mean proportion or our sample proportion to our actual true proportion of the entire population. And so to kind of break it down, confidence intervals are used as a range that likely holds the true proportion population parameters. So like I said, it's essentially using what we found with the sample and then comparing that and using the confidence interval to show our true proportion of the population. And because we had a 95% confidence interval, this leaves us with a 0.05 alpha for us to compare our p-value to. So for us, we had a pooled 95% confidence level of negative 1.8722 and negative 1.0407. So the confidence interval does not contain 0, which is very meaningful, very significant, because if 0 is not within the confidence interval, then it shows that there is significant change, because for us, 0 indicates that they are the same. If you're doing mu1 minus mu2, you want to get 0 to show no significant difference. But for us, 0 is not within our 95% confidence interval. It's not in that range. So we know that there is a significant difference between the two groups. And then kind of going off of that, because our confidence interval does not contain 0 and it shows significant change, we would expect a small p-value to go against the null hypothesis. And the conclusions. So the p-value essentially represents the probability, but that's under the assumption that there's no difference between the comparisons. So for us, our p-value is 0.0001, and is less than alpha in this case, which is 0.05. Because of our 95% confidence interval, we know that alpha is 0.05, which gives us strong evidence to reject the null hypothesis. And then we believe that there is significant difference between the placebo and control groups. This is coming off of our confidence interval. This is coming off of our data. This is coming off of all the everything that we have found to this point. And then we come to this conclusion with evidence is from the confidence interval, but also just from the p-value itself. Because it's so low, we are comparing that to alpha. And so the percent chance of it being right, of this being just one of those times that it's outside of the confidence interval for some reason, are very low. And so the probability of that shows with a 0.001 p-value, which leads us to believe that the null hypothesis is not true.
And then this is our SAS code that we used. This was the SAS code for part 1. It was just a lot of proc means, proc univariate, and proc SG plots to find the basic statistics, the descriptive statistics, and then to make the images. And then this is a little bit more, just another proc univariate with different variables. And then this was our SAS code for part 2, which was just a t-test and then another proc means that we